Hi, and thanks for stopping by our showcase. My name is Randy Graham. I'm the Chief of the Science and Technology Integration Division, Central Region Headquarters, and my co-author is Tommy Grafenauer, who's the SU at WFO Grand Forks. You can see several other people listed that have been very involved in this effort as well. And what we're going to talk about today is the use of ensembles and probabilistic information to develop key messages as part of a modernized forecast process. The National Weather Service and NOAA have been moving towards the use of ensembles and probabilistic information for quite a few years. The NWS strategic plan in 2019 indicated that we need to harness the power of ensemble modeling as the starting point for NWS forecast operations and to help us quantify uncertainty. The Building a Weather Ready Nation through Science-Based Service made the comment that people make better decisions, have higher trust in information, and or display greater understanding of forecast information when shown a tailored probabilistic forecast instead of a deterministic one. This is based on social science findings across many disciplines. So why now? Well, if we go back to 2000, we had 10 global ensemble members that were available to forecasters in the National Weather Service, and the resolution was 200 kilometers, which you see there in the upper right. We basically got mean, spread, spaghetti plots. There were no cams. Now we have access to 100 global ensemble members. The resolution is 9 to 25 kilometers. We have access to the NBM, anomaly information, M-climate, EFI, shift of tails, reforecast records information. We have several CAM options now. So what does this look like? So to move forward, it's kind of a merge of the human and the machine element. So the machines are good, and the models are good at identifying potential outcomes. And then our job as meteorologists and hydrologists is to provide context and value. Communication of forecast information requires us to have a deep understanding of both atmospheric science and partner thresholds in decision making. So the expectation of meteorologists needs to broaden to include translating forecast elements and impacts into actionable, impact-based decision support services. Forecasters must go through the forecast process in the most efficient and effective way possible, leveraging ensemble and probabilistic information to develop the appropriate message. So what does this look like? We have a team of SUs and WCMs in Central Region and Science and Technology Integration Division representatives working on providing guidance on this modernized forecast process. You can see an infographic there on the right that kind of talks about this. It's not a cookbook. It's a way of approaching the forecast process. We use ensemble and probabilistic tools to identify messaging opportunities, not opportunities to edit the grids. A messaging funnel helps us identify the appropriate communication strategy based on our confidence. For example, we may be very confident in a heat wave in days 5, 6, 7 and can message it very confidently. Other times our confidence may not be very high until 12 or 24 hours out before the forecast. We might have to take a different approach, and the messaging funnel helps us identify which communication strategy we should take. Another aspect of this is modernizing the area forecast discussion. We're going to leverage key messages based on the messaging opportunities that we just talked about, and those will be at the top of the AFD. There will be plain language to be bottom line up front kind of approach. Also in the AFD, we're going to have an increased inclusion of ensemble and probabilistic information in the discussions, and we're going to use those ensemble tools to help us contextualize the forecast. We're going to limit the words of estimated probability because people have very different interpretation of those things like probable, chance, likely, and if they are utilized, we're going to have percentages in parentheses behind them to add appropriate context so that they're not misinterpreted. And finally, probabilistic messaging is a really critical aspect of this. So we had a probabilistic messaging survey in 2022 with over 2,500 responses from EMs, transportation officials, and school superintendents. And some of the key findings were that NWS partners are able to make use of probabilistic information conveyed in different ways. The vast majority of partners found that large snow forecast ranges, such as 3 to 10 inches, are useful as long as we provide appropriate context on why the range is large. And finally, probability of exceedance graphics were found to be extremely useful by a majority of the partners surveyed. So this is a really exciting effort for moving forward. We would love to have any discussion and ideas from you all, so feel free to reach out to Tommy and I at our email addresses there. Thanks again for stopping by our showcase.